Okay, so now what we're going to talk about is loops. So loops are usually broken down into the three most common versions of loops is for loops, while loops, and then what's called a do-while loop, which is another name for repeat until, which was originally in a programming language called Pascal. We want to talk about infinite loops because that's one of the biggest programming bugs you have to watch out for. There are also go-to followed by labels and break statements and continue statements. So, so what we want to do is we want to, let's say we found ourselves in a situation where we're doing something repetitive. So for example, suppose we wanted to write a program and for some reason we wanted to print all the numbers between 3 and 10, right? So we wanted to print all the numbers between 3 and 10. Okay. So if our programming languages use the word print to print out a value, we could say print 3, print 4, print 5, print 6, print 7, print 8, print 9, print 10. And our program would be done. We'd be typing the word print a lot. And if we were asked the question, could you print the numbers from 3 to 100, this could be a lot of typing to write the program to do it if we did it this way. Another way we could do it, you might at first think, why bother doing this? It looks like unnecessary extra work. Suppose we had a variable called I, and we assigned I to the number 3, and then printed I. It would do the same thing, it would print a 3, it's just now we're taking 2 steps. I'm really writing 2 lines of code. I'm using a semicolon to say, okay, that's the end of that line of code. The fact that I'm writing it on the same line horizontally doesn't change the fact that this is really 2 lines of code. So I've now doubled the number of lines of code, and what I'm doing is I'm putting I into a variable and then printing the contents of the variable. Then I put a 4 into I, and then again I print I. And then I put a 5 into I, and again I print I. So you might think, this is just a slower way of doing this. Why would I even bother doing this? But I want to illustrate this is something we could do. Now suppose that instead of changing the value to I to the next number before what it was originally, suppose I wanted to do this. Suppose I wanted to set the variable I equal to 1. That's my first step. Then I decide I'm going to repeatedly do the same thing over and over and over. I'm going to print I, and then I'm going to say whatever I is, add 1 to it. So it would go from 3 to 4. So my variable would be 3. I would print 3, and then I would make I become 4. It would become 3 plus 1, which is now 4. Right? Okay. Then I would print 4, and then make I go from I would equal I plus 1. I would make I go from 4 to 5. Then I would print the 5 and make I go to 6. Then I would print the 6 and make I go to 7. And I would print the 7 and make I go to 8. Print the 8 and make I go to 9. Print the 9, make I go to 10. Print the 10 and make I go to 11, but I would never print the 11. So you might think, isn't this the simplest way to print out all the numbers from 3 to 11? Why add all this overhead? But here's the thing that's interesting. Notice that we initially made I a 3, so that's like a separate step. But then every one of these 2 steps are identical. We are doing the same 2 identical lines of code over and over and over until we hit a point where we say, all right, we're done. Somehow we have to stop. We knew to stop down here. So we are running these 2 lines of code in a loop. We just keep doing these two, these two, these two. Same exact lines of code over and over and over. What's changing is the variable I. It's popular in computer science to use the letter I when you're iterating through a series of numbers. That's why we use I. I is going from 3 all the way up to 11, and then we decided to stop. Considering the fact that we are repeatedly doing these same 2 lines of code over and over and over, we could, instead of writing it over and over and over, we could write it once, like this. We could say for I equals 3, that's our first line of code right here. The thing we have to do initially to get things started, you could say for I equals 3, we have a Boolean expression, an expression that could be true or false. As long as I is less than or equal to 10, we're going to keep doing this over and over and over. What are we going to do? We're going to print I. We're going to print I, which is what we do here. Print I, print I, print I, print I, print. At the end of this series of statements, and it's only one statement, we're going to run this line of code at the very end. And then we're going to come back up to the top and we're going to evaluate, is this statement, is this Boolean expression still true? And if it is true, we will run the loop again. So we're going to repeatedly do this. Keep doing this as long as this Boolean expression is true. As soon as it becomes false, we're done. So these 2 lines of code with this open bracket and closed bracket is exactly equivalent to these 1, 2, 3, 4, 17 lines of code, right? 1, 2, 3, 4, 5, 6, 9, 10, 11, 12, 13, 14, 15, 16, 17. So these 17 lines of code could be done with these 2 lines of code. You're basically saying the same thing. You're saying initially, this line of code runs once, just like this. Then you're saying whatever is in this open parent, closed parent block runs repeatedly. And once that block finishes, this line of code runs. And then after this line of code runs, we then check this Boolean expression to see if it's still true. And if it's still true, we run it again. So this code and this code is identical. Now, if I was to ask you, could you write the code that prints all the numbers from 3 to 1,000, you're going to be cutting and pasting, and it'll take you out for hours. With this, all you have to do is change this 10 to 1,000, and you're done. So that's the beauty of the for loop. So the flow chart, and we know this from using Flowgorithms, the flow chart for a for loop is you do your initialization, I equals 3, get everything started. Then you ask yourself, is the Boolean expression true or false? Right, that would be if I is less than or equal to 10. If the Boolean expression is true or false, if it's true, we run our statements that are in the loop. When the statements are done, we come up here and we either increment or decrement I. And then we ask ourselves, is the Boolean expression still true? If it's still true, run the statements, increment or decrement, ask yourself if it's true. Keep running this as a loop. Eventually, it has to become false so we can leave. If it doesn't become false, ever, then we have a programming problem that we have to make sure it doesn't happen, because then a program would never run. Okay, so we have another type of loop called a while loop, which is actually very similar to the for loop. It gives a little bit more freedom to the programmer. So basically, a while loop is really a repetitive if statement. So suppose, for example, I said I equals 3. So I assign the value of 3 to I. And then I say if means if the Boolean expression that's about to come is true, then the code in the block will run. If it's not true, it won't run. Right? So this is an if-then statement. Right? Remember we talked about if-then and if-then else statements. If I is less than or equal to 10, then open paren, close paren. So all the code between the open paren and close paren will run if the Boolean expression I is less than or equal to 10 is true, and I is equal to 3, so it is true. So this code should run. So this would print I and then add a 1 to the value of I. So it would print 3, and then I would become 4. So that's what this code would do if we're using an if statement. If we remove the word if and put in the word while, what have we done? Well, here, I equals 3, and then we say while, keep repeating while this statement is true. While the statement I is less than 10 is true, run this repetitively. So what would we do? We would now say print I, which would print out a 3, and then I would become 4. When you get to the bottom of the code, you don't leave like you would here with the if statement. You don't just run it once and keep going. You go back up to the while, and you check once again, is this statement true? And if it's true again, run the code in the loop again. So now it would print 4, and then it would make it a 5. I would become a 5. Then it would go back up to the top. Is 5 less than or equal to 10? True. True again. Print 5, make it a 6, go up here, print 7, print 8, print 9, print 10. Eventually I will become 11. When I becomes 11, right after we printed 10. When I becomes 11, we will go up here, and this statement is 11 less than or equal to 10. That will now be a false statement, and therefore the code in the brackets will not run, and you would jump down here and finish. So this code, with the if statement, this will print the 3, and I will be 4 when you're done. Change if to while, and this will print 3, 4, 5, 6, 7, 8, 9, 10, and I would be 11, and then the code would be finished. Because the Boolean statement is finally false. Okay. So loop syntax goes like this. For for loops, we have the word for, open brackets, you write your initial statement, like x equals 3. Your initial statement. Then you put in a Boolean statement, something that has to be true to make the loop run again. It has to remain true to make the loop run again. And then we have our final statement, which we said usually is to increment or decrement some number, and that number eventually causes the loop to stop running, but it doesn't have to be that way. And then we have open bracket, close bracket, and we put in a block of code that runs repetitively every time the loop runs. So we have an initialized statement that's run once before the loop starts. The Boolean expression is evaluated every time before the block runs. If true, the block runs. If false, it stops. And the final statement is run after the block of code is run. So we do all of our statements in here, then run this statement, and then ask ourselves, is the Boolean expression true again? And if it's true, the code will run again. So that's the syntax for the for loop. If we were to do a comparison, for against while, some of you may like the for loop, some of you may like the while loop. I guess that's a preference if you want. The for loop goes like this. We have our initial statement, our Boolean statement, and our incrementing statement. So as I'm reading this, I can see the variable I is going to go from 0 all the way up to 10, and each time it runs, it's going to get incremented by 1. And then this block of code will run. So basically, this block of code will run 11 times. 0 all the way through 10. From 0 to 10 is actually 11 unique numbers. If you want to write the while loop equivalent to that for loop, The first expression, which is the thing that runs initially before the loop starts, you have the responsibility of writing that as a separate line of code. You have to say integer I equals 0. Instead of it being part of the for loop, you write it as a separate line of code. A while loop only has one expression, a Boolean expression. So your Boolean expression, I is less than or equal to 10, shows up in the while statement. While I is less than or equal to 10. Keep running this loop while this statement is true. So you would write it here. In a for loop, which forces you in the header to write the code that runs at the end of the loop, which hopefully will make this Boolean expression eventually become false, so your loop will stop running and your program can finish. You have to manually put that line of code at the end of your block of code. You have to say, okay, now I equals I plus 1, and then go back up and see if the statement is still true. So you might think for loops and while loops are really identical. It's just a matter of how you like to code. Do you want to put all three statements in the for loop? Or do you want to pepper them where needed? I'll put my initializer here, I'll put my Boolean expression here, and I'll put my increment expression here. Otherwise, it's the same exact thing. So you could Google, are for loops and while loops identical? And some people say yes, and some people say no. The while loop gives you a little bit more freedom because you could have multiple lines of code setting up your initialization. And you could have a lot of different scenarios on whether you want to increment or not increment yet until. So there's a little bit more freedom with a while loop, and freedom usually means there's more of an opportunity for you to make a mistake. So it's up to you. They're not identical. They're not identical. But here's a slide that shows, how one is identical to the other. They're not necessarily identical. The while loop gives you a little bit more freedom. Okay, so one of the things as we're coding up loops are great because you can do a lot of work in a few lines of code as long as you're going to do something repetitive. If you work at a bank and you're going to go through everybody's bank account and give them interest, it would be nice to write a quick little loop that will do it all, rather than writing out thousands and thousands of lines of code because you have thousands and thousands of customers. So loops are great. Have to be very careful you do not cause an infinite loop. So for example, suppose we had a for loop that went for I starting at 3, as long as this Boolean expression is true, the loop keeps running. I is less than or equal to 10, great. We increment I, so it should go from 3. Each time it runs, it goes 4, 5, 6, 7, 8, 9, 10, eventually hits 11 and the loop stops. What if you erroneously put in your code I equals I minus 1? So what this code would do, this code right here, what this would do, it was I would be 3, I is less than or equal to 10, so the loop would run. We would print the 3, I would become 2, and then this line would run at the end of these two lines, and then I would become 3 again. So then we'd come up to the loop again, 3 is less than 10, we'd print 3, it would become 2, it would become 3, and this thing would just print 3 forever. It would never stop. This loop would just run forever. You would never finish. You'd just be printing 3s all day. So now if you've ever been sitting at a computer and you have a bunch of windows open and then you click on a window and the window goes gray, it kind of like goes dim, and then it's just not responding. Would you like to kill this window? And whether you say yes or no, it's going to get killed anyway. So they ask you, would you like to kill the window? Sometimes the issue is the program running in that window went into an infinite loop. It's not ending. Sometimes. There's another issue that comes up. We learned in your operating systems class. Okay, but anyway, here's where the programmer coded up a for loop and put an error in and went into an infinite loop. Here's the while loop equivalent. Not equivalent, but a different story. I equals 3, while I is less than or equal to 10, print I. But we have to put in I equals I plus 1, otherwise it'll just always stay 3. So this is a while loop that will print 3 forever and never stop. Now sometimes multi-threaded programming, sometimes we do want to have code that runs forever. For example, when you plug in an electric clock, if it has software that runs the clock, you might have an infinite loop that says while true, which means it's going to always be true, run the clock. Take whatever time it is, add 1 second to it, wait for a second, add another second, and just do that forever. That's, that's rare. Like I say, this would be multi-threaded programming. There'd be another thread, another piece of code running that could eventually kill the clock or change the time of day. But that's sometimes, that's by design if you want to have a loop that runs forever. Normally, you do not want to write code that goes into an infinite loop. So Apple computers out in Silicon Valley, out in California, they have headquarters. And in their headquarters, these are their buildings, right? And then there's a road that goes around all their buildings. And it just keeps going in a circle. And they asked the town that they were in if they could rename that road to Infinite Loop. So Apple's headquarters has a road that goes around it called Infinite Loop, which I don't think is a good idea. It's a software company, Apple, right? And the name of the road that goes around its headquarters is actually named after a programming error, Infinite Loop. We kind of like jinx the company by having the road go around its headquarters named after a programming bug. But anyway, that's what they decided to do. Okay. There's a third style of loop that's called the do-while loop. It's not a while loop, it's called a do-while loop. And in older programming languages from the 1970s, it was also known as a repeat until loop. So the way this loop would work is, instead of saying while at the top and having a Boolean expression, you say do, open brackets, close brackets, and at the end of the code in the loop, you check the Boolean statement. So basically you're saying run this code, and when it's done, check if the Boolean statement is true, and if it's true, run it again. So now the question is, what is the difference between a while loop and a do-while loop? Right? And like I say, in the programming language Pascal from the 70s, they would say repeat. They'd write some code, and they would say until, and they'd put in a Boolean expression. Until the Boolean expression becomes false. Until the Boolean expression becomes true. So they'd have to write the negation of it. Okay, so now the question is, what is the difference between a while loop, where you say while, Boolean expression, and then write the code below it, as opposed to a do-while, which is where you write the word do, you say open paren, you put in the code, and then you say while, and you check the Boolean expression. The only difference between a while loop and a do-while loop is a do-while loop, the code is guaranteed to run at least one time. It's guaranteed to run because it runs without checking the Boolean expression. So even if the Boolean expression was false from the beginning, the code would run at least once, and then you check the Boolean expression and it would be false. So why would you ever want to do a do-while over a while loop if you were in some kind of a situation where you wanted the code in the block to run at least one time? So you could have a situation where you're, let's say, reading data from an online service, and you open up a file, and then you go into an infinite loop where you're reading, it's not an infinite loop. You go into a loop where you're reading input from a server, and you're writing it to a file. And then at the end, you have to close your file, right? So no matter what, you have to close the file, no matter what. So you might have code in here that closes the file that has to run at least once. So that could be a situation where you say, I don't care if the Boolean expression is immediately false. Let's say I'm going out to a server and I'm getting data from it and the server's down. So I might have a Boolean expression, while server is up, keep reading from it. It might be immediately down, and I want to run my block of code at least once because in my code I say, well, if the server's down, close out the file, something like that. But it's very, very rare. It's not common to use a do-while loop. Just, you know, for loops and while loops are the most commonly used expressions. Okay. So a long, long time ago, programming languages had labels in them, and you could put labels that kind of like comments in code, but you can actually in your code say, go to this label. You can make your code jump to some label. Then there was a big, you know, argument before the internet. So people didn't blog on the internet, but people would write textbooks describing that go-to statements are dangerous, and a lot of programming languages took them out. Now they're making a comeback. So the idea is like this. You could say go-to with labels. You could simulate the do while. So you could say loop start, write a block of code, and then say if condition is true, go to loop start. So that's effectively just another way of writing a do while loop. Right? And you have a block of code, and then you say, hey, if this condition is true, do it again. And just keep doing that. Right? Very similar to a do while. So go-tos are used in C, C#, Perl. And the argument goes like this. This was the argument why it was always said that using go-tos is dangerous. Suppose you had code that had label A, you do some stuff, and then you say go to label C. You jump to label C. You do some stuff that says jump to label B. Then you do some stuff that says jump to label A. And then you do stuff and it goes to C, to B, to A, to C, to B, to A. This code is in an infinite loop. It is inherently the way of jumping from label to label. It will run in an infinite loop and your program will never finish. And you can't see it because sometimes you're jumping forward and sometimes you're jumping backwards. And this time you're jumping backwards and then you're jumping forward. And what you have to see is when you're doing your jumping around, you're jumping into a circle. Maybe you are jumping into a circle, maybe not. So that was the big argument that you could pepper your code with labels and then eventually put your code into an infinite loop because of how it's jumping around labels, and you can't see it with your eyes. It's not like a for loop where you can see why is this thing going into an infinite loop. But then the argument came along that says, well, if you're going to jump, if you're going to go to somewhere, as long as you always go forward and not backwards, you'll never go into an infinite loop. If I'm here and I want, you know, if these are lines of code, each one of these dots is a line of code, and I could either go forward to the next one and forward to the next one and forward to the next one, or at this point I jump to here, then go forward and then jump. As long as I'm jumping forward and I never jump backwards, I'll never go into an infinite loop. Then I started thinking, all right, go-to statements as long as you go forward is okay. So they do get to be convenient. But they're also error prone and worried about going into infinite loops. Okay, so loops with exit when, which simulates a do while. So we can have a loop, run some code, and then say exit when this Boolean condition. When this Boolean condition becomes true, we exit the loop, which is effectively saying jump to the label at the end of the loop. So it's like the do while, except the Boolean expression must be true to exit, not true to stay in the loop, but true to exit. Okay. So this introduces the break statement, and a lot of arguing says you should never have a break statement, but the idea is like this. We could say for I goes from 0 to, as long as it's less than 10, we keep saying I equals I plus 1. That's just shorthand for I equals I plus 1. We print out the value of I, and then we have a line of code that says, if I is equal to 3, break. Get out of the loop. We're done. So what this code would do is it would print 0, then I would become 1, it would print 1, I would become 2, it would print 2, I would become 3, if I equals 3, break out of the code. So then we would leave the code, and we wouldn't count all the way up to 10, or 9. Let me see about this. Print I, if I equals 3, we break. So actually, it should have printed 3, right? 1 from 3. Okay, good. And, all right. Then there's the idea of the continue. So this is where we're using implied labels. So here we're saying I is going to be initialized to 0. As long as it's less than 10, we're going to make I equal I plus 1. And then we're going to say if I is equal to 3, we're going to continue. Now what does that mean? Oddly enough, what it means is we're going to break out of the loop, go down to the bottom of the loop, and then come back up to the top and keep going. In other words, the code after it will not run for that particular iteration of the loop. So what this code would do is it would print 0, 1, 2, it would skip the 3 and go 4, 5, 6, 7, 8, 9. So we're saying for the special case when I equals 3, what we're really trying to do is break out of the loop but keep the loop going. We're breaking out for this one run. So we're saying continue running the loop but skip this iteration of the loop. So continue is not the greatest word in the world for that. It should be something like break and leave. Okay. Now, it's possible you could use loops, and inside of loops you could have other loops. So suppose, for example, we have an array of 6 elements. Okay. If we had a function that tells us the length of an array, how many elements are in the array, that would be great. So we could say, you know, the size of the element, let's say, equals 6. So now we'd like to read through all the elements in the array, starting at 0 and ending at 5, one less than the size of the array. 0 through 5 is arranged for 6 elements. We can say for each one of those, so we're going to go from 0 to 5. Then we're going to say for j equals the value of I, as long as j doesn't hit the end of the array, we'll print j. And then we'll print in a space. So what this will do is when I equals 1, when I equals 0, j will go from 0 to 5. It'll print 0, 1, 2, 3, 4, 5. This loop will finish, print 1, 2, 3, 4, 5, and then it'll print the space. Then we'll go up to here. I will now become 1, and this inner loop will run again from 1 to 5. So then it'll print 1, 2, 3, 4, 5, and then print this space. Print the space. So it'll print 1, 2, 3, 4, 5. This loop will end. It'll print the space. It'll come up here. I will become 2. I equals I plus 1. I will become 2, and then the inner loop will run again and print all the numbers from 2 to 5, and so on. So this is where we put a for loop. We create a for loop, starts here, ends down here, and inside the for loop we have another for loop. We have loops inside of loops. That's certainly allowed. Makes the coding very interesting. Okay. So suppose, for example, we wanted to take an array of numbers that are not sorted, right? We have 8, 5, 7, 1, 9, 3. So you guys may not realize it, but when you're on your cell phones, you're probably several times a day hitting buttons that are causing data to get sorted. So if you go to buy a ticket for a concert, you might say, give me the concerts in, cheapest tickets to nicest tickets, or, closest to the stage. Hit closest to the stage, resorts all the available tickets. You go on Amazon.com, you could say, sort them by the quickest delivery time, sort them by the cheapest price. So you're constantly sorting data. Constantly sorting data. So suppose we wanted to take an array of numbers and write them in sorted order. So there's one algorithm we could use called selection sort. And what we basically do is we take the first variable, right? So we have an array of numbers. And we say we're going to swap the first one with the lowest number in the whole array. So we're gonna go through we're gonna run a loop, a nested loop. I'm gonna say for I equals the first one, then I'm gonna have J go through all the elements in the array and find the smallest one. And when I find the smallest one, I'm gonna swap that with the first one. So how can we do that? The size of the array equals whatever the length of the array is. For I equals 0 to going through the whole array, we're going to take the maximum number, the first number that we read, we're going to say that's the maximum number. And then we're going to say for j equals I all the way through the end of the array, we're going to say if the minimum value, if the value we read is less than the minimum value, so that should actually be minimum, sorry about that. So if the value we read is smaller than the minimum value, then we update the index where it is and we update the value. We update the minimum value and we update the index. So here's what we're basically doing. We're saying I want to swap this 8 with the smallest number in the whole array. So I'm going to read this one and this one and this one. As long as I find a smaller one, I'm going to remember it. So I found this is the smallest one. I'm going to remember its location and its value. So the smallest value I've seen so far is a 1. I ask, is 9 less than 1? No. Is 3 less than 1? No. So I swap the 1 and the 8. So how do we swap them? Here's the line where we do the swap. We take the value in location I, which is the first one, that's the 8. Save that into a temporary variable. Take the value in the minimum one, copy the 1 over to this location. And then we take the temporary value and copy that into, take the 8 and copy it into this location. So now we effectively swap 1 with 8. Now, so we have the outer for loop starts at the first one, and the inner for loop goes through them all looking for the smallest variable. When we find the smallest variable, we swap them. Now we increment to the next set, the second one. Go through the whole array again, find the second smallest number, swap those two. So now we got a 3 here and a 5 here. So that means this section of my array is the smallest and the second smallest. Everything after that is in kind of random order. So now we take this location and we read through all of these looking, we go through the inner for loop, reading through all of these looking for the smallest value. Here's the smallest value. Here's the current value. Swap the two. So now I have 1, 3, 5. We now grab the 8, look through these 3 numbers, look for the smallest number, swap them. So now we have 1, 3, 5, 7. Now we look at this one, find the smallest number in the remaining part of the array, swap them, and we're done. So this is called the insertion sort algorithm, which takes an array of random numbers and sorts them. Okay. So there's other, since we're talking about for loops, there's other ones where this is in JavaScript, the for of loop. This is just kind of like some ancillary material, depending on your programming language. But we can have an array of a person. We could have a first name, last name, how much they weigh. You could have a collection of attributes, and then you could say for a variable of this array. And basically, it will go through each element in the array and take on its value. And you would be able to then print it out. So like I say, this is just other, mutations of for loops. We could have the for in, which is a set associative array. So we can have an array, a person, and we could say, well, their first name is this value, and their last name is this value, and their weight is this value. And the reason we could do that is then we could have a series of people, and then you can individually ask, what is this person's last name? And then you won't have to go reading through the array, because a set associative array would know to go to the last name field and return that value. So then we could do the for x is in this set. We could say print out the values, and the values and the names of the values, print them out as pairs if we want. But like I say, this is just different programming languages doing various operations that are inherently for loops and while loops. So we could use a range and stop, and the stop is the number of integers, whole integers that it will generate. So starting from 0, for example, if you said range 3, you would actually be declaring an array that goes 0, 1, and 2. So rather than declaring an array, you could say range. You could put a start value, a stop value, and a step value. So you could also say range 99, 2, minus 1. So what this would do is create an array starting at 92, count negative down to 2, and so on. So if you want to, you could look through these slides at the end, just seeing all the different things you can do with for loops, or mutated versions of for loops. This is something in Python. We can have an array called fruit. You can have an apple, an orange, and a banana. And then you could write a for loop that says for x is in fruit, print x. And this would just print out apple, orange, banana. So basically, instead of you having an integer start at 0 and count up to a number and then index into the array, it basically will assign every element in the array to the variable x. When it hits the end of the array, it knows to stop. So there'd be no chance of an infinite loop. So it's removing some error proneness. And like I said, they're just mutated ways of using the for loops and the while loops. Also in Python, we could say this. We could say x equals 1, while true. Obviously, we have an infinite loop. This will print counting to infinity. And this is some formatting. We'll cover Python formatting later on. And then this is equal x equals x plus 1. So this would be an infinite loop that counts off to infinity. Okay. All right. So that's our talk on loops.